From Shield Studio 22A, this is the Safety Synergy Podcast. I'm Elliot Laratonda. My guest today is Tristan Hess. Tristan Hess is the Service Bureau Manager for OriginLabs. He holds a bachelor's degree in interior design and a master's in education focused on art and design. Before coming to OriginLabs, he worked for an independent school in Colorado where he taught architecture, design, and digital fabrication classes. Thanks for being here, man.
Yeah, thanks for having me.
So one thing I wanted to call out, this is a collaboration with SSMC. So Tristan, Jose, and the gang at OriginLab representing SSMC Student Shop Manager Consortium. I am the liaison from SHIMA to that group. So this is a good opportunity of professional development, education. This link and podcast will be shared with both groups in case anyone can learn something from either side of the house. We're going to get right into it, and I'll let Tristan please first give us an overview of OriginLabs.
Yeah, so basically we're a resource for prototyping and fabrication. We're located in downtown State College. We have a couple different arms of OriginLabs. We have the makerspace, the service bureau, and then we do have a student outreach coordinator. So basically what that boils down to is if you want to build a project yourself or if you want to hire us to do it on your behalf. So makerspace, you would get trained on the tools that you want to use, come in when we're open, work on your project. Service bureau, maybe you need a little help getting started. You're not really sure what you're going to do for your design. You can contract us out to do all of the CAD work, all of the fabrication, and we use the equipment that we have at our disposal to build your project.
Gotcha. So we had a podcast with Jose, who is the supervisor of the Makerspace arm, and Tristan here supervises the Service Bureau arm. Could you key in a little bit more on the Service Bureau and what it provides for the community and your role and how you interact with customers and all that?
Yeah, so we're kind of set up for prototyping for products. So if you have an idea for a product that let's say you want to do furniture design or something, you've never done that before, you don't know where to get started on that. You could set up a meeting with myself. I would take you through, some of the things that you're trying to figure out. We could talk about design of the furniture that you're looking to do, and then you could contract us out to, hey, we want to do some prototyping in this area. That's, a wider conversation of, doing sketches, doing CAD programs. Maybe we do some stuff on some of our equipment to get started.
So the makerspace is, I have the skills and knowledge. I'm going to come in after I get the right training and use the tools and equipment to make what I want to make. But the Service Bureau arm is, I have an idea, but I need some professional help. Yep. And whether it's through design and CAD and drawing and all that, or whether it's the fabrication, digifab, additive manufacturing, or you have the mill and the lathe.
Yep, we'll do some of that too.
Yep, and you have the CNC downstairs. And we're going to talk through some of this equipment focusing on digital fabrication, specifically 3D printers and laser cutters. And that's kind of the title of our topic today. So the framework of our discussion going forward is we're going to cover a piece of equipment. We'll talk about its general operations and use cases. I'll ask Tristan about maintenance or management tips, and we'll cover the safety implications, right? Because that's what this is all about, tying together operations related to digital fabrication and management integrated with safety. First area of the shop here, we have our photo the audience can see, and we're talking about the Formlabs 3 and 3L printers. So can you tell us about this, Tristan? The equipment, operations, or use cases?
Yeah, they're Formlabs printers. The largest one will do about the size of a motorcycle helmet. It's basically using a laser and light to cure resin as it's printing. This one is, your parts are hanging upside down as they're being printed. It gets submerged into, whatever resin you're printing with, and then basically the laser will go back through, cure the resin. The resin, yep. There's a number of different types of resins that we can print with. We've got engineering grade resins. We've got just kind of basic draft resins, depending on if you're just doing quick prototyping versus something that's going to actually be used. Maybe you need it to have a little bit more mechanical properties for building up to, the elements, what have you.
Sure.
There's a lot of different types out there. We do, for project examples, we work with a toy company called Basic Fun. They're based out of Florida, but they have someone locally here. We will do small batch runs for them, printing in the various resins that we have to get their toy prototyping out the door for them.
That's a great example. So stereolithography, SLA printers, you mentioned in this case, the build plate is inverted, right? So it's going to lower down, dip in that vat of resin, and the laser is going to kind of cure it in place and repeat until you have your build. Does that kind of sum it up okay?
Yep. And then once it's done printing, you'll take your parts off, and then the machine in the bottom right is our wash station. So that gets any of the uncured resin off, because there's a little bit of a tackiness to the prints once they come off. And then the final cure is the kind of the microwave looking thing, and that makes it, contact safe after it goes through that.
Right.
And there's different times and temperatures associated with it, whichever resin you're printing with, that you'll set it to, and then you'll put your parts in for that duration, and then you can take them out, and then it's safe to handle after that.
Gotcha. So the build is complete in the 3D printers that we see on the screen there on the left, 2 different sizes there. Afterwards, it goes in the wash basin, which is filled with IPA, isopropyl alcohol there, bottom right, and then it makes its way into the UV curing station, top right there. You mentioned multiple resins. That can come in handy, of course, depending on the customer spec, whether it needs to hold up to high temperatures, whether it's just a cheap draft material, a couple different color options there. Clear could, of course, come in handy. So depending on the customer's needs, would use different resins, thus different resin cartridges and bases that the machine would draw from underneath of it.
Correct.
Any tips related to management or maintenance of these machines?
Yeah, we will. Obviously, you don't want to ever mix your cartridges with your tanks and everything, so make sure things are properly labeled. You always want to be gloved up when you're working with this, just for the machine safety and then your safety as well.
Sure.
Sometimes as your IPA gets more saturated, you may need to dunk parts for longer, just to make sure that all of the resin is off of the final part before you put it into the UV station.
Got it. So one thing I wanted to clarify about safety implications, you mentioned resins and gloving up, right? So that's a good idea. Personal protective equipment, depending on the resin type you have. Of course, we would advise to look at the safety data sheets of all resins. They can be a bit different. Yours is relatively tame, though not something you'd want to directly be breathing in, inhaling for long periods of time in poor ventilation. This lab space has great ventilation, and we'll talk more about that later. So main idea would be skin contact prevention. So gloves are a good idea, perhaps clothing or maybe a protective garment. The other safety implication we wanted to point out is both of these units, or all 4 of these units, are fully contained, right? They're not opened. In this case, they would be contained related to any emissions that they might give off. The other thing I wanted to point out is the IPA, that bath there. I know that there's a shelf or a mechanism, right, that allows you to put the part in, close it, let it be submerged in the bath, but then it's not like you're dunking your hands in it to get the part out, right?
No, it fully comes up and everything.
Right.
And then, like once you're either post-processing the prints, getting them off of the build plate, afterwards you will, kind of want to clean up the area, because sometimes the resin can spill onto the surface. So making sure that you have a surface where you can actually like wipe it down afterwards would be important too.
Yep. Again, good ventilation in this space would be important. We know the IPA would be flammable there, so we'd want to make sure that we have good ventilation related to the fire hazard. And then, of course, the UV curing box is going to be interlocked, and we have UV protection built in of those screens there. So next up, we have the Stratasys J55 PolyJet printer. This one's full color. It's also an SLA style printer. Can you tell us about this machine, how it maybe is different than the ones we previously saw?
Yeah, this one's a bit different, where the curing, the printing, everything is being done internally. So there really is no washing of parts in the same sense that you would wash the Formlabs prints. The support structure is printed in there as well, but it is taken into a pressure wash station, and then you basically just pressure wash it off of the parts when you're finished. And then you'll need to do a full clean, depending on the length between prints. You may need to do 2 of these, but there's a wizard in the machine for a cleaning routine. So after printing is done, you'll want to clean it, and then if you go 4 or 5 days after to do another print, you may need to do another one just before. But this one is super important. They're all, obviously all the machines are important to wear gloves on, but this one you're going to be in the machine actually with optical wipes and IPA for cleaning and everything, to clean all of the little components that are in there. Yeah.
So this printer, like the last ones we saw, also uses resin. It's also an SLA type. Differences being that this is full color, multicolor, right?
Yep,
Previously,
PolyJet,
we'd have to select the resin type that's going to constrain us to one color for that build. But here we get multiple colors coming out of the nozzles at the same time to really do a full color piece. And one example is I always remember the slice of pizza sitting on the desk. And so that also used scanning technology. I understand we scanned a real slice of pizza, put that into the file system, into the machine, and it printed out a crazy realistic looking slice of pizza.
Yeah, so you can imagine for product and prototyping development, if you're trying to get, it's not going to give you a fully workable prototype, obviously, but if you're trying to dial in textures, colors for, scaling your idea up, this is a great machine to test on just to get some of those things dialed in before you move on.
And the other difference that you mentioned is this has a build plate that's right side up, if you will. Parts aren't inverted because the jets are depositing material downward, right? We don't have that dunking kind of process we did in the other ones. I'm also seeing a fume extractor here on the machine. So the other machines that we previously saw are self-contained. This one does have a fume extractor that's going to scrub the emissions of this machine and provide us for safe kind of local exhaust ventilation. Sounded like the maintenance or management tips here were related to cleaning, careful cleaning. We talked about kind of the same implications for safety on this machine related to skin protection, gloving up, that kind of thing. And this is an area that we've mentioned a couple times. We talk about how this post-processing center is used here.
Yeah, we do. On the right, we do keep our IPA in that flammables cabinet. And then on the left is our pressure wash for the PolyJet Stratasys 3D printer. So that's where you take your parts, drop them in there, and then pressure wash them off. And then the bucket that's in the sink is for our metal 3D printer. So we'll submerge parts in there just to make sure all of the powder is out of the parts before moving over the bandsaw.
Next up is the OriginLabs fuses. So this is the first type of printer that we're looking at that is selective laser sintering. So we're going from a powder directly into our solid. And I know you guys use nylon and TPU. So tell us about the stations, the machines that we're seeing here.
So the machine on the left is the printer. If you open that door up, there's a build chamber in there. That's where all of the powder is going to be directed during printing. And then, yes, as it's going through, a laser will sinter that powder together to create your solid part. And the unsintered powder acts as your support structure. SLS is really nice because you don't have to worry about building any sort of support structure. Once it's done printing, it does need to cool. You can take that build chamber out and place it into the machine on the right, which is your sift. It's sort of like a recycling post-processing system once your parts are done. You can load the build chamber up into there. It'll tell you how much time it needs to cool, and then you can come back and post-process your parts. The reason you want to wait for the temperature to cool down is because if you raise it up too soon, may not fully reach the potential of the material if you pull it out too soon, and then it also is very hot. And then you pull your parts out of there, move it to the center of the machine, and then it becomes almost like an archaeological dig site where you're scrubbing away the excess powder until you get to your fully formed part. The powder goes into that kind of white circular area is your sift. You turn the machine on to sift it, the powder kind of gets mixed or vibrates and goes down into there. And then there is on the far right, probably can't see it in this image, but that's where your fresh powder goes. And then there's something called a refresh rate, which is the mixture of old powder to new powder. You fill with a collection area at the bottom, and then that gets taken out, put on the far right of the machine, and then cycled through to mix it all together, and then it gets dumped back into the Fuse 1 or Fuse 1 Plus, whichever one you're using.
So to recap, your build comes out of the printer. We're going to take it over to the SIF for cooling, so it serves that purpose. Then we're going to dig out our part, so there's going to be some powder, of course, like contained into this shroud. And so it also serves a purpose of safety in that I see the vacuum hooked up. It's going to kind of act as local exhaust or a downdraft table to capture some of that particulate.
Yep, yeah, there's a filter in there. So once you turn it on, it all gets sucked away from you.
Nice. Yep. And then our residual powder from our dig is going to be captured from the system to be reused, combined with new powder, and then placed back in the machine.
Yep, exactly.
Gotcha. So obviously the main safety implications here is potential health hazards associated with these particulates, the TPU or nylon powder. So we have the local exhaust, or anything else come to mind for kind of maintenance or management, or maybe we
Well, actually, yeah, for the printer, you'll want to use IPA and an optical wipe to get something called the IR sensor clean, and then the camera up above. And I'll usually wipe some of that stuff down internally before I start the print. And then you do just want to make sure that your powder has been mixed before. It usually lasts about a week inside of the machine before you need to take it out and remix it. Otherwise, you'll run into some printing errors.
The other safety implication that came to mind is potentially a class 1 laser system, right? Depending on the power of the laser inside, we might want to test those interlocks and provide some application to a laser safety program. So that applies to any of our selective laser sintering models that we're covering here. So next we have a metal printer, exact metal, XM200G. Tell us about this guy.
You can do a variety of different metals on this printer. We have opted to just do stainless steel just because in order to do different metals on there, you have to clean the entire system out, so that can become very time consuming to have to do that. And then it also gets expensive once you get into it's already an expensive machine.
And then you have more exposure because you're
Yes.
cleaning out to transfer for different powders.
Yep.
And then we have more and more potential exposure to those powders, which we'll get more into. But
Yes.
operational advantages as well. So we use stainless steel. Go ahead.
Yeah, and then this one we do the full respirator mask and everything, gloves. Whenever that door's open, if you're working on the machine, you always want to have the PPE on.
Examples of parts that would come out of this, I can imagine that little Nittany Lion statue produced from stainless steel. Any others come to mind?
Yeah,
use cases?
we have done some stuff for some professors on campus that are doing research. We made this kind of helical device for some sort of thing that they were, some part that they needed. It ended up, I don't think, working out, but it did actually print exactly how we anticipated it to, which was really nice. This one is SLS, but there are different rules associated with this printer. So you still, in some ways, have to treat it like FDM printing with your overhangs and everything. So there is a support structure built on that just comes off by hand afterwards. And the part is fully fused to the build plate. So we will take it to the bandsaw after this. And then the tub that was in that image where the pressure wash station was, we'll fully dunk the part into water just to try to get all of the powder out of there, just so that way, once you move it out of the printer, you're not potentially breathing any of that in. And then, we'll take it to the bandsaw to cut.
To recap and probably oversimplify, there's a container of stainless steel powder. There's a laser inside that is sintering that powder directly into solid metal based, of course, on your build plan. Safety implications, we talked about powder handling. I did want to point out that we can see the explosion-proof vacuum right next to the machine. That's going to provide our local exhaust ventilation. When this machine is running, of course it's closed. It is directly ventilated. Even when employees have to work inside, we talked about the importance of cleaning or maybe changing out powders would be necessary. You also have that protection of local exhaust ventilation. Tristan did mention that to be conservative and safe, and per the manufacturer's recommendations, they do wear a powered air purifying respirator that is connected to a face shield, so a positive pressure respirator that provides fresh air. I know you guys also have potential use of a traditional tight-fitting air purifying respirator, and for all these reasons, the employees here, and only employees that would do these tasks, go through the respiratory protection program, get fit tested, medically qualified, that kind of thing. One thing to point out too related to safety, for operational advantages and for safety reasons, the lab only uses stainless steel. The stainless steel powder really isn't too bad at all. We've looked at that SDS, mostly related to potential long-term exposure. The material is not flammable or combustible, so we don't have to worry about implications of fire safety and specific electrical design. If you're using aluminum, titanium, things like that, we might have to worry about that. So be careful on your metal selection and think about the safety implications and work with EHS ahead of time based on those selections. That covers the 3D printing room. Right next to that room, we have our laser cutters. Here we have the Trotec Speedy 360 laser cutter, so cutting cardboard, wood, maybe glass, kind of basic materials like that. So tell us about these machines, kind of how they work, how people use them, maybe a use case example.
Yeah, a lot of our CNC equipment is staff operated. These laser cutters you can actually get trained on as a Makerspace member. So take a training and then you can come in, and when we're open, book them out for about $6 per hour. You can book it up to 4 hours at a time. Yeah, these are awesome pieces of equipment for prototyping. We can, for the service bureau, use them to get parts out quicker, especially if we're oftentimes design things for cardboard first before I take it to, maybe our metal laser CNC or our CNC router just to test things out, get the proportions kind of dialed in. And then customers can also do, end use things. We've had researchers come in, we've had students come in and use them for, making coasters, making Christmas ornaments.
Sure, gifts.
We've had research professors in making things for the lab. So they get a ton of use. They're probably our most popular pieces of equipment, and they're pretty fun to play with.
Any maintenance or management tips?
Yeah, there is in the nozzle, there's a lens that you need to clean. We do it about once a week. That'll depend on how often it's getting used. But yeah, we'll go through with gloves. We'll put the proper solution on the lens and wipe it all down, put it back in. There is a grate at the bottom that we'll take out, and we'll vacuum any of the waste that's down there. And then we do shut our machines down 30 minutes before we close, just for fire safety hazards and everything. And then there's an air filter that we have on the back that we will replace as needed.
These machines definitely have a enclosed, high-powered laser, so we would definitely test the interlock here. We have a basic training for laser cutters, operators, users, employees, some safety implications to point out beyond that. We see that we have ductwork. Both of these machines are directly tied to local exhaust, so that's the ideal solution. We have the point of operation being directly exhausted. I have seen laser cutters just like these that use a fume extractor. One pro tip there that comes to mind, we worked with a laser cutter where the folks were using the fume extractor at, say, 80 to 100%. That was actually too much airflow. It created kind of a turbulence, and it wasn't really effective. We worked with the manufacturer to discover that if they toned it back to, say, 40 or 50%, it was much more effective. Local exhaust being the ideal ventilation. We also see a non-combustible trash can there. We know from experience that using a non-combustible receptacle is much better than, say, plastic or something else. Of course, your operation wants to have strategies for cooling material, maybe even a spray bottle or something to make sure it's cool before putting in the trash. But in case someone forgets, it's a good idea to have a non-combustible trash can so it doesn't turn into a larger event if there's a smoldering piece of material. We also see, I think in the back there, a fire blanket. We have fire extinguishers in this room. Last machine to cover is our metal laser cutter. Can you talk about the make and model and kind of how it works, some details?
Yeah, it's a Kern fiber laser. It can go through 1/2-inch plate steel, 3/8 aluminum. It's a super powerful machine. It's there are some maintenance procedures that you have to do before you run it each time. In the back, you'll want to turn on your pneumatic air system and make sure that the vials don't have any sort of moisture accumulated. You'll want to make sure that the F lens is clean. So, before you operate it, there's a latch on the front of the laser in the gantry system. You'll want to open that door up and make sure that your F lens is nice and clean. If it's not, you can pop it out, replace it, and then put it back in. And then every, I forget the number of hours, but you'll want to grease the axis points on it. Yeah.
This one seems to have the most maintenance and care advice associated with it. Very capable machine. So use case example would be I put in a piece of sheet metal. You mentioned the thickness up to like 1/2-inch plate steel, which is impressive. And I put in that sheet good and out I get, for example, a cutout piece of metal that displays the logo for my business, for example, something like that.
Yeah, and then we do have different gases associated. We push with oxygen and nitrogen.
Yes, so probably for when it needs to burn hotter, right? Stronger, thicker material, I'm guessing, is when we use oxygen.
Yeah, what I've been given direction on is when you're doing like small intricate parts, you want to use nitrogen.
Okay.
And then on the others, you want to use oxygen.
Got it. And I remember we worked through some advice with Jose. It was kind of challenging to find the right transfer line that was compatible with the high pressure oxygen that the manufacturer was calling for. That's something we collaborated together with EHS and OriginLabs to find the right braided stainless steel line that was compatible with both fittings on either end as well as the pressure. We also we talked about a lot of service or maintenance tasks. So hopefully our listeners are thinking about the implications of lockout tagout and energy control. This machine definitely has an energy control procedure with multiple energy sources. Anytime that we are going to do that service or maintenance, we'd have to be applying hazardous energy control. And of course, we mentioned the high-powered laser. This most definitely would be included as a Class 1 laser system, an enclosed, interlocked, high-powered laser inside in the implications of that program. So we have some questions here. Some I came up with, some audience members from the prior podcast webinar pointed out. So first, Tristan, can you answer, why doesn't OriginLabs have any FDM printers? So fused deposition molding, right? That's the right acronym there. Why don't we have any of those common 3D printers that probably most people are familiar with that I could buy on Amazon, have in my house, that kind of thing? It uses different types of plastics or media. Why don't we see those, and why don't we cover those today?
Yeah, because they're so widely used and other spaces on campus and in the community offer those, we wanted to stay away from them as to not undercut their spaces. So we opted for SLA. It also, and SLS. It also gives you a higher resolution when printing. So the parts that you're going to get are a little higher brow, I guess. FDM printers are great. There's definitely a lot of use cases for them, but the resolution on ours will be slightly more improved.
Yeah, those resources are much more accessible on campus and in the community. You want to provide a different level of service.
Yeah.
How do you charge for 3D prints?
Yep, they're billed by the gram. So depending on what resin or powder you're going to use, it ranges from about 30 cents per gram to 50 cents per gram, metal being the highest. And then the draft resins, the non-engineering grade resins will be the most cost effective.
So when using the Service Bureau for 3D printing, someone would expect to pay for their material by the weight and then also the labor associated with that build?
Just the weight. We will, like, if we do small batch runs, we will include labor fees into that. You know, if we're doing all of the slicing for, let's say like 25 parts or something.
Significant time.
Yeah, we have to do that. We have to change all the prints over, and there's a little bit more time involved with doing all of that. But yeah, basically, you will, on our website, there's a 3D print request form, fill that out, specify what kind of material you'd like to use, what kind of printer, what number of parts that you're going to run, and then upload those files. They come right to me. And then I'll slice them, give you a quote along with a screenshot of your part sliced in the software. And then once you give us the go-ahead, we will run the job.
Awesome. So from our last session, Brian K. asked what the ventilation rate at the OriginLabs were. So assuming we're talking about the 3D printer room with probably the most concern of health hazards, I did look into that, and based on the CFM and volume of the room, it's about 9 air changes per hour. Lab ventilation recommended to be above 5 up to 10. So we're at the high end there, 9 air changes per hour. Good ventilation in the space. This is why I've referred to several times throughout this session that there's good general dilution ventilation in this space. From the last session, Christy D asked about PPE in general. So I'll bring it back to PPE used commonly in that 3D printer room. So anytime that we're handling resins or nylon powder or any of the powders, we're going to be gloving up. So nitrile gloves are going to cover us for those materials. Always, of course, refer to your safety data sheets for recommended PPE. In our case, we really do have good ventilation, low durations of exposure. Chances are a respirator would not be required, but that is dependent on hazard exposure assessment. Also for us, we mentioned that we do use the PAPR respirator for stainless steel powder handling and cleaning. That is because the manufacturer does recommend it. And even if it's a conservative approach, the guys have no problem going through the medical qualifications and fit tested related to using that respirator, their tight-fitting APR. Another question that came up is, could we generally characterize hazards of 3D printer media? And what you're seeing here is an attempt at that. So I have common 3D printer media and a very informal risk characterization of each. I classified these into 3 categories. First being things I would definitely evaluate or look closer at. Any use of a metal printer, namely because of powder handling and the health exposure there, but also because of the potential combustible atmosphere it can provide, depending on the metal powder used. Any non-enclosed ABS printer. Of the FDM type printers and plastics, ABS probably has the worst rap. So anytime I would see an open, non-enclosed printer that uses ABS media, I'd probably look closer at that, at the ventilation, how people are exposed, exposure durations, things like that. If I see a 3D printer that's totally custom, lab made, because labs are doing this, right? There's research about 3D printers, and sometimes they make their own or maybe modifying an off-the-shelf printer. I would definitely look closer and evaluate that. The category under I'd ask some questions about, that would be any resin printer. We talked about liquid resins have different risks associated with them, so I would be looking at those safety data sheets, looking at personal protective equipment associated with liquid resin handling specifically. Nylon or other powders, again, specifically related to the health hazards of those powders. Hopefully you have local exhaust ventilation like we saw in this presentation. Any FDM printer that's used in a non-ideal location, small rooms where we have small volumes of air or poor ventilation, I'd definitely look a bit closer at that, maybe even regardless of the media used. In the category of I wouldn't really worry about it would be totally enclosed FDM printers, whether they're directly ventilated or have a filter, other than changing out that filter of that enclosure. Enclosed FDM printers, I probably wouldn't look too much closer at. And then any FDM printer that's using PLA, PETG, or PVA. Those are generally characterized as our lower risk materials related to health exposure. So if those are enclosed, of course, or in a space with just good, decent ventilation, I wouldn't worry about those too much. Of course, exposure can vary depending on the application, environment, time of exposure, and things like that. But this, I think, generally summarizes a pretty informal way of characterizing risk of 3D printer media. So I think that covers everything. We talked about various machines in your digital fabrication area at the OriginLabs. We focused on 3D printers and laser cutters. And thanks, man. I hope it was fun. I hope it was a good experience.
Yeah, thanks for having me.
Yep. So thanks, everybody. I hope you learned something. Feel free to reach out and we can continue the conversation. Thanks a lot. We'll sign off.